So now we have finished learning all types of linked lists and explored different operations that can be performed on linked lists. Now in this video, let's compare the time complexity of all operations that we perform between array and linked list. It's very important to do so because knowing the time complexity of different operations on these data structures helps us to select the best option for our case. By the end of this video, you will be aware of in which situation array is better than the linked list, and similarly in which situation linked list is better than an array. So let's start to look at these operations one by one. So the first operation here is creation. So we know that creation of an array takes O1 time complexity, and similarly creation of linked list takes O1 time complexity, because here we are just creating a node and assigning a value to it. So the next operation is insertion, and we know that we can insert an element in 3 different ways. So insert an element at the beginning, inserting an element at the end of collection, and insert an element in the nth position. So let's look at these 3 cases one by one. So inserting an element at the first position is constant time operation for both array and linked list. And similarly, insertion an element at the last position is constant time operation for both data structures over here. So as you see, insertion an element at the last position for array and for linked list is O1 time complexity. Now insertion of an element at the end position is better in arrays than linked list in terms of time complexity. This is because if we want to insert an element at the end location in an array, we can directly go to that location based on the index and insert value there. On the other hand, in case of linked list, it's O(n) time complexity, because if we want to insert an element at end position in linked list, we have to traverse through linked list until this position over here. So we know that traversing through linked list takes O(n) time complexity. That's why inserting an element at end position takes O(n) time complexity. Now the next operation is searching operation. So here we will look at first searching an element in an unsorted data. Here it takes order of n in array, because to find an element we need to traverse from beginning of an array to the end until we find the element that we are looking for. In case of linked list, it's also same, because here again we need to traverse through linked list to find the element that we are looking for. But if we are searching for an element in sorted data, in case of an array it is O log n, because here we can use binary search algorithm. So the logic behind the binary search algorithm will be explained in the upcoming lectures. So here I'm not going to in details, but here I just want to mention that it's applicable for sorted data, and if we used in array, the time complexity for searching will be O log n. So in case of linked list, if we are searching for a value in a sorted data, it's again O(n) time complexity, because here again we need to loop through the data until we find the value that we are looking for. So it takes O(n) time complexity. So the next operation is traversing. So it's obvious that for both data structures it's O(n) time complexity, because here we need to visit each and every element of collection and print its value. So here for both of them it takes O(n) time complexity. Now the next operation is deletion. So here again we have 3 cases: deleting the first element, deleting the last element, and deleting the nth element. So deleting the first element in case of both array and linked list is constant time operation, because in case of array we are just deleting the element based on the index, and in case of linked list we are just changing the references of the node. So now the next operation is deleting the last element. So deleting the last element in case of array, it's constant time operation, because here we can directly go to the last cell and delete the value based on its index. But in case of linked list, it depends on the type of linked list. So deletion might take O(n) time complexity or constant time operation. In case of single linked list, it's O(n) time complexity, but in case of double linked list, it's constant time operation. So we have explained these cases in our previous lecture. So if something is not clear, you can go back and watch these lectures related to deletion. Now the next operation is deletion of an element. Again here, in case of array, it's constant time operation, because here we can just directly access an element and delete it based on their index. But in case of linked list, it's O(n), because here we need to traverse through linked list until we reach the nth element and delete the element from there. So it takes O(n) time complexity. Now the next operation is deleting an entire data structure. Here, in case of an array, it takes O(1) time complexity, but in case of linked list, it depends on the type of linked list. So if the type of linked list is single linked list, it's constant time operation because here we are just updating the tail and head references. But if it is double linked list, we need to traverse through double linked list and update the all nodes previous values. So this takes O(n) time complexity because here we are visiting each nodes of double linked list and updating the previous values. So this is why it takes O(n) time complexity. Now the next operation is accessing nth element. So we know that accessing an element in the array is done based on the index, so we are just writing the index name and accessing it. So the location of cell in the memory is predefined. That's why accessing an element in array based on the index takes O(1) time complexity. But in case of linked list, to access an nth element, we need to traverse through linked list until we reach this element. So that's why it takes O(n) time complexity in the worst case. So this is all for this lecture. And with this lecture, we have completed another section which is called linked list. So in this section, we have learned 4 different types of linked list and performed various operations on them. We have also learned what is the time and space complexity for these operations that we performed on different types of linked list. Now in the next section, let's see interview questions that are asked by big companies like Apple, Amazon, Facebook, and Microsoft during their interviews that are related to linked list. So see you in the next section.